Okay, so we're going to continue with our investigation of correlation coefficients. So put your date at the top. And we touched on this briefly before. So, the idea between this is how closely the x and y variables are. Okay, so like we had the other day, it was the year and the people attended the dance. So the R value, or the correlation coefficient, would tell me how closely related the year and the number of attendees is. Okay, so our relationship, this correlation coefficient can be a strong positive, a strong negative, or it can just have no relationship at all. It cannot be related. And we use the letter R to stand for correlation coefficient. So when you're talking about correlation coefficient, you use the letter R. So R equals. Okay. So this site, oops, that's not what I meant to do. This site kind of really shows us, gives us a good idea of what the R values are. So it can have a strong positive or a strong negative relationship, and they give you a couple examples here. So perfect positive, and when they say perfect, they mean like the R is equivalent to 1. That's what that one means. And you can see this, I could draw a line perfectly through all these points. So that means these two, whatever they graphed here, if it was years in attendance or what it was, is perfectly related. One reflects the other one 100%. Okay? So now this one would be an R equals 0.08. So it's not quite perfect, but you can tell the number, the points are tight, and they're definite rising from left to right. So they're somewhat tight against a line in the middle. So we would say that's about an R.8. Now this is an R.03, right? So like I can still tell that these are going up, but if I were to draw a line between them, I mean these are really scattered about from left to right. So that we would call this a weak positive or low positive correlation. You know, 0.9, 0.8 would be a high positive correlation, and a 1 is the perfect. This would be an R equals 0. There is no relationship with whatever you're graphing on the X and the Y value. They're just all over, right? So that would be an R equals 0. And then you can have the same thing here, but with the negative. This is a negative relationship, which means something's decreasing, right? So it doesn't make it less, it just means it's going down. So again, this would be an R equals a negative 0.3. So again, that's low, because if I were to draw a line, and I can't seem to draw one well, but if I were to draw a line through there, they're scattered all about. They're not tight. You're really looking for the tightness of the line. Here, this is a high, because again, if I were to draw a line, they're much closer to like a line of fit if I were to draw this. And this is perfect. So again, these are R values. So we got to get good at understanding what the R is and predicting the R. Okay, so as they said down here, one is perfect. One affects the other one for sure, and it's a straight line. 0, they're not related at all, no correlation. And negative 1 is a perfect negative correlation. So you might want to take a minute to write some of these examples down so that you have a good understanding about what these numbers mean and how they look on the graph. So we'll pause for just a moment for you to write those down. So on these, we're going to kind of guesstimate what we have the R's. If I had a calculator and I wanted to take the time and plug each one of these points in, I showed you how you could get the R. But I'm just going to sort of guesstimate what I think these are. So if I were to draw a line between here, looking at our notes, we could probably guess that this is a R of around 0.8. So we would say it's a fairly strong positive. And the reason I know that is if I were to draw a line through the middle like I was trying to do right there, we'll see if we can do a better job here. You know, they're fairly tight. We're really just kind of looking for the tightness of the points to a line of best fit that we would draw. Okay, so I would say this is a strong positive. If I looked at this one, you can see the difference between this and this. These are a little tight. These are much more spread out, right? So if I were to draw a line, I don't know why I keep doing that because it's just not working very well. But if I were to draw a line, you can see those lines are spread out quite a bit. So you could probably estimate that as, you know, on our notes over here. Oops. That looked like almost a 0.3. And it might be something a little bit different. It might be like a 0.4 or 0.2, but this again, we would say this is a low positive correlation. And if I had to guess, I might say R is about, you know, 0.4, maybe 0.3. Okay, so I'm going to have you take a couple guesses on the next ones, and we'll talk about this in class more tomorrow. So I want you to try this one. What do you think this one would be? What kind of correlation would that be? And then I'd like you to try this one. Hopefully you know this one. And lastly, give this one a go. And then you'll have a good night, and I'll see you for block scheduling tomorrow. Make sure you bring drinks and snacks.